I will be talking today first about, in general, about industrial energy efficiency and energy management systems within the United States, and then ask some questions together about how we can build upon the knowledge we already have and the experiences we have to make sure there is consistency in the quality of implementations of management system standards, as well as the results in the communication of the energy savings that occur and how we might collectively proceed with that idea. So first, I'll provide a context about industrial energy efficiency in the United States, talk about the limitations of the project-based approach to energy efficiency. Might be a little redundant and because you have such an experience with energy management systems already. Talk about ISO 50001 and the United States Department of Energy Superior Energy Performance Program, the program that Graziella mentioned earlier. The need for transparent, high-quality workforce to implement and verify the performance of an energy management system, and as well, energy performance improvement. I'll discuss the university-based U.S. Department of Energy Industrial Assessment Center program. And then, as I said earlier, ask the question about the workforce development, and is there a way that university programs can serve as the basis for a high-quality energy management system workforce? And this may build upon a lot of existing programs in universities that already provide great services. First, the United States Department of Energy industrial energy efficiency programs are voluntary. As Graziella said, there's no laws, there's no tax incentives, there's no regulation, there's no national policy that encourages industrial energy efficiency. So the Department of Energy acts with a mandate to improve efficiency, but without a lot of ways to go about that other than promoting the idea for voluntary improvement. The Department of Energy does offer a range of industrial energy efficiency programs. These programs include technical assistance. Someone would come help you explain how to improve your boiler. Self-reporting savings programs for companies to be recognized for improvements in energy performance when they self-report energy performance improvement, as well as an energy management system program that includes a foundation of ISO 50001 certification, as well as verification of energy performance improvement. The Department of Energy's focus has shifted over time from focusing on equipment improvements to systems, and now to a facility and management system-based approach. This is now the foundation on which the Department of Energy drives continual energy performance improvements. These can include technology uptake, encouragement, operational control, and behavior change. The Department of Energy energy management system ethos, its general thinking is that these processes should be transparent, they should be data-driven results, and that there should be verified performance improvements and continual improvement of energy performance. As I mentioned, we'll be talking about the Superior Energy Performance Program, as well as an Industrial Assessment Center program that's offered by the Department of Energy. And the question that I'll pose at the end is, can such programs at universities offer a platform for energy management system workforce development that'll be robust and accepted by industry? The background of the project-based approach to energy efficiency is simply a one-time pass at performing an assessment to identify energy performance improvement projects. These projects are then competed against other priorities within industry and commonly lose out. The projects are implemented, and that savings may or may not be quantified after implementation. Usually they are if there's a financial incentive. They may not be communicated to the top of the organization or down to the people that work on the factory floor making products. They're not connected to the overall performance of the facility. They're limited to the single equipment that are being replaced or single project being undertaken. And they typically degrade with time as there's no continual improvement process to maintain the equipment and increase its performance. This results in a roller coaster of saving energy, degradation of energy savings, and the process being repeated when the organization realizes that its equipment is breaking or they're losing money. This again is focused on equipment and processes typically. We have conducted studies of multiple STEAM system assessments where an assessment would be conducted at a facility, recommendations made for implementation, and then a year and 2 years later, the assessors would contact the facility and find out what did you implement and how much did you actually save. And what we found was that the opportunities that were implemented the most had relatively very small impact related to the total energy consumption of the facility. They also were very cheap, the size of the circle, and they typically focused on maintenance issues such as repairing steam traps, repairing insulation, or other types of repair. The more impactful opportunities were implemented at much lower rates. They're very costly. They typically required an incentive to be implemented, but they weren't being driven because these projects were being competed against other priorities within the organization. And when you look at the project-based approach to improving energy performance, you see that it's missing a lot of elements within an industrial organization. While there's a focus on equipment and processes, typically it does not focus on materials and the source of energy. It typically does not talk about the connections between people and the priorities of people within an organization. It may or may not include controls, but it certainly does not look at an entire organization from the facility on in and how the facility can improve operationally as well as look at its basic understanding of its need to consume energy. The question of, do you need the boiler at all? Typically does not come up in assessment because you've paid the assessor to improve the boiler already. By implementing a strategic approach to energy management, such as been documented in ISO 50001, the roller coaster changes to having senior management commit to the program, initially saving energy typically through operational improvements, making in capital investments and maintaining those savings, and repeating the process through a continual improvement system. The Department of Energy has taken the foundation of ISO 50001, and as Graziella mentioned, while 50001 requires that you set an improvement target, it doesn't say by how much or demand that you report if you've met it or not externally. The U.S. Department of Energy created this voluntary program that recognizes excellence in energy management through certification to ISO 50001, as well as achievement in energy performance improvement through third-party verification of energy savings. There's a minimum level of 5% improvement after a 3-year span. So a baseline year, and 3 years later, an assessment to see how much energy the facility has saved compared to that baseline. There have been over 60 certificates to the superior energy performance issued in the history of the program now. This is a sampling of the ones that have been certified. And you'll see that over a 3-year time span, facilities improve by significant amounts. This is facility-wide, not just program savings, project savings, ranging from about 6% up to 30%. There are 4 facilities that are highlighted in green. These facilities have achieved 2 certifications now to superior energy performance. They've gone through first 3-year cycle and a second 3-year cycle. We can look at the publicly available results of these companies' energy performance improvement and see that the ideas that 50,001 promotes of continual energy performance improvement are borne out. That in their first certification, this facility received a 15% improvement, and at its next, a 23% improvement against a common baseline. This results in an over 35% improvement for those 6 years. This other facility, the first year achieved 7% improvement, all from operational improvements. There was no capital expense. There was no new equipment bought and installed to achieve this certification. We also are very fortunate in that a number of facilities gave us data about their energy consumption and energy performance improvement from the time before they participated in the Superior Energy Performance Program and after they started participating in the program. And what we can see is that for before participation in the Superior Energy Performance Program, these facilities on average were improving at about 3% a year, which is very aggressive for a manufacturing facility in the United States. Typical improvement is about 1% a year. But we see that even these aggressive facilities, once they have implemented an energy management system, are now improving at a vastly higher rate. They're now improving at about 14% a year. As they learned about ISO 50001 and implemented their management system, at first the savings did not increase, but they increased as they started to take operational control of their equipment and then started to make capital investments to further their improvement. And then we see once the management system is in place, the savings are sustained instead of degrading over time. Of course, we would always want more data to continue this trend outwards. We're in the process of receiving that. From the Department of Energy's perspective, they look to the third-party certifications of ISO 50001 and the performance improvements to be certified to superior energy performance as a way to scale the program to a large number of participants while decreasing their own financial investment. So as the program started and was in a pilot stage, DOE provided consultants, metering and monitoring equipment, paid for group-based trainings regarding 50001 and the performance improvement targets, as well as administrative services for the program. Since then, the Superior Energy Performance Program has gone through a number of demonstration phases and is now in full launch. And as the program has matured, the investment from the Department of Energy has decreased. No longer does the Department of Energy offer consulting services. It no longer pays for equipment, and it no longer offers group learning about ISO 50001, except for the cases where they are pushing the Superior Energy Performance Program into a new sector, such as the water or wastewater sector. But there are a number of tools that the Department of Energy has developed over time to support ISO 50001 and the Superior Energy Performance Improvement Program. This includes a measurement and verification protocol. This is a free document you can download online and clearly states how to calculate energy savings at a facility and document and show what savings were achieved. This is very important not only to the Superior Energy Performance Program, but any program around the world, as it allows, this concept allows then for very comparable results. So one facility says, I saved 5%. The second facility says, I saved 10%. Can you compare them? You can if there's a foundation with a clear protocol to follow. They've developed an energy performance indicator tool. This tool is Excel-based and allows for facilities to perform regression analysis to calculate energy savings and helps the facility calculate how much they've improved based upon the measurement and verification protocol. They also have produced the eGuide, is an online tool that walks companies and individuals through understand the basic principles of energy management systems through ISO 50001 and the Superior Energy Performance Program. Another major initiative that the department started was the Institute for Energy Management Professionals. This is not an academic program. This is meant to certify professionals that will go and be consultants to help implement ISO 50001 and SEP. This is meant to help people that will lead audits and meant to help people that will be doing performance verifications of savings have a certificate that can be shown to the facility and to be shown to the public to say this person knows what they are doing and that the results that they say will be accurate and meaningful. Why does professional certification matter? For some of the reasons I just mentioned, including confidence in the implementation of ISO 50001, that the implementations are consistent and have value, that the results are comparable, and that there is an impact from implementing ISO 50001. Otherwise, you end up with a piece of paper on the wall and no value to either the company or the country or the world. Inside a company, this is an important question to make sure they're receiving value for their investment. It's important for a consultant to be able to show a company, I have the qualifications to implement ISO 50001 with you in a meaningful way. It is important that when a ISO 50001 verifier comes to verify implementation, that they understand the standard and that they are able to say to the company and to the rest of the world that yes, this company has implemented ISO 50001 correctly, as well as if there is performance verification of savings, that these savings are comparable because they have followed a certain protocol and that they have meaning both to the company and to the outside world. If there are regulators of a supply chain or domestic or global people that are interested in seeing ISO 50001 being implemented or savings being accounted for, they would like to have confidence that the certificates being issued have value and are trustworthy to the intentions of 50001. So how do you build this workforce? The Department of Energy started the Institute for Energy Management Professionals, but that starts with people who are already in their professional career. And we're posing the question of, should you be starting sooner? And we have examples here in Colombia of programs that train people in energy management systems. And we look at that saying, that's fantastic. What can we do with that? How can we grow something similar that helps university students learn about ISO 50001, energy management systems, as well as technical engineering so that when they become professionals, they can go to facilities and help both with the management system component of ISO 50001 as well as the engineering and energy savings component of ISO 50001. Because of these two interwoven business management and engineering components to 50001, universities offer a great place to learn these skills because they already have courses and materials and professionals that focus on engineering, business management, and communication. So instead of receiving just a singular degree, perhaps in engineering, you'd be able to receive an engineering degree with a certificate saying, I also understand energy management systems. This is also a skill set, understanding energy management systems, that will ever be growing in demand. As industry and as supply chains and as national governments demand energy management systems as the foundation for energy efficiency, students that graduate from universities with such programs will be in demand and able to find jobs. That's difficult right now as energy management systems are relatively new to industry globally, some places more than others. But what we see in the United States is an increasing demand for people with this broad knowledge base. I'll speak in detail about a singular program in the United States. This is the Industrial Assessment Center program. It has two goals. The first, to generate energy savings, productivity improvements, and water and wastewater savings by providing no-cost audits to small and medium-sized manufacturers. These are professional quality audits that include an educational component in that students assist full-time professors and faculty in conducting these audits and preparing reports. So there's an education component to generate the next generation of energy efficiency engineers. This program is almost 40 years old. There are 24 facilities in the United States that have an industrial assessment center program. Since 1981, there have been over 16,000 assessments performed. And note that the relationship between industry and these assessment centers took time to build. That at first industry would ask the question, why would I want a university and students to come to my facility and tell me how to improve? But by showing that the assessments were of professional quality and led by faculty, and that the students were assisting the faculty, it was the faculty reaching out to industry, there was a growing confidence in the quality and value of this assessment. It also doesn't help that it was free. These are the locations of the different assessment centers. And as I mentioned, they're professional first and they're educational second. And that it is the center director, a tenured engineering faculty member with an interest in the practice of engineering, that leads these assessments, and that these assessments are a teaching tool for students that participate. And there is a report that is provided 60 days after the assessment with an annual follow-up, and that these reports are very well formatted, professional. They're not an average university student laboratory report that you may or may not want to read. An industrial assessment center assessment includes pre-work with the facility to ask them about their energy consumption and use, on-site 1 or 2 days of assessment that is faculty-led, and then the writing of the report. These assessments focus on equipment and processes and controls. So they're not focused as an energy management system on all aspects within an organization, but they focus specifically on equipment and controls, mostly because of their historic nature of the program before the Department of Energy was focused on energy management systems, but also because that's where engineering students tend to focus their efforts. They don't focus their efforts on people and organizational structures, communications, or other aspects that are included in energy management system standard. The IAC program is very impactful. Each manufacturing that receives an assessment typically has 130,000 US dollars identified in savings, and they implement about half of the opportunities identified. 60% of the students that graduate with a certificate go into work in the energy field. And there is an ever-growing database that includes all of the assessments, recommendations, implementations from the Industrial Assessment Center online. So the question then is, for the United States, can the Industrial Assessment Centers be a platform to develop an energy management system workforce that is of high quality to increase the number of ISO 50001 implementations within the United States? Right now, within the ISO 50001 PDCA loop of continual improvement, the assessment could be used as part of the energy planning process, but that would be about the extent of its impact. The question then is if that assessment can continue as it exists, but now incorporate energy management system coursework and perhaps some component that includes a gap analysis of current management system practices and what ISO 50001 requires, perform a one-day basic training at the facility, give a primer on 50001, help the facility go through the Department of Energy e-guide, or work with professors and students together to help a facility with ISO 50001 implementation. These all have question marks because we in the United States have not really worked on this question. And that's where we come to, what can we learn from you? Because you have universities with programs that educate at a variety of levels about energy management systems. And so because ISO 50001 is a global international standard, we should be responsive and look at countries around the world and how they are training workforce and how they are making sure that there is robust implementation of 50001. And Colombia is a country that we can look to. We should be examining the current practices here that occur to educate workforce, understand how your industry approaches ISO 50001 and that workforce, share best practices between countries, as well as create research partnerships to improve energy management system impact and uptake. And we have already begun to collaborate in the foundation of the Global Impact, ISO 50001 Global Impacts Research Network. This is a new research group that is international, includes 15 or more country representations from academics and policymakers around the world. And we collectively are looking to develop a methodology and tool that will help policymakers around the world understand what the potential impact of ISO 50001 is in their own country, so that policymakers can use their own country's energy consumption and context and understanding of how policies go about being developed and programs are designed to understand what targets of savings they can expect from ISO 50001 for themselves. So in conclusion, again, make the point that 50001 is complex in that it includes both energy management, the management of business, as well as the management of energy consumption and the technical aspect of saving energy. And that the need for globally consistent implementation and verification is required for the standard to have value. If there is no consistent implementation and acknowledgement that each implementation has the same amount of impact, then there's no trust in that the standard is meeting its designed obligations. That a professional, well-qualified workforce is needed to ensure this energy management system implementation and certification is conducted so that there is confidence in the energy management systems, that this is a global challenge, and then we need to look to make sure that the next generation of energy efficiency experts will be able to execute the system implementation. And because of the diverse offerings within a university, to ask the questions if universities offer a great starting point to train the next generation of energy management system experts. With that, I say thank you again and welcome any questions.